We discussed about shared pool, right? Shared pool is of two components. One is library cache, data dictionary cache. Data dictionary cache contains metadata and statistics. Library cache contains the cursors
Cursor.
where your statements, passcodes, execution plans are stored. Now, not only your SQL related, your PL SQL related cursors are also stored here. PL SQL programs. When a PL SQL program submitted, it has to be compiled and a compilation code will be stored. It uses again a cursors memories to store your PL SQL. So all your SQLs and PL SQLs, everything is stored in your. Now going to the next part today, we'll talk about this one of the biggest, another big component. What is this called as? Buffer cache or cache. Okay, buffer cache. When a user connected server process, user process, buffer cache, and we understood few things. Your system, sysocs, different files. Okay, this is my which file?
User data.
Users that data file, and we also understood that my table blocks are taken from here and loaded into the buffer cache or cache. So what is this buffer cache or cache? Buffer cache is a chunk of buffers. Chunk means pieces. Chunk of buffers, pieces of buffers. What is the size of each chunk or each piece here? It is the size of your, what is this? What is this here? Block.
Blocks.
What is the size of my Oracle block by default?
8K.
8 KB.
Okay.
So 8 KB, right? Your chunk size is also going to be 8 KB. Simple. Why? Whenever it is doing an IO, minimum to minimum, it will read one block. So whenever it is reading a block of 8 KB, even you query for one row, one column, and also you want only one column, the entire block will be loaded. So entire block will be kept here. It will scan that row, take that one column you wanted and returns you. But the entire block is loaded into memory. Done? Continue? Right. While it is bringing the data from the disk to memory, who is loading data from disk to memory? Who brings data from disk to memory? Server process. Who is taking your metadata, statistics and keeping in data dictionary cache? Server process is responsible to load data from disk, from file to memory, from disk file to memory. The question comes up, server process, can he go and take whatever the memory area I wanted in the buffer cache? Buffer is a chunk of buffers, pieces of buffers. And I told you what is the size of a buffer. In single buffer 8 KB. An example buffer cache is nearly 20-30% of your SGA. If 10 GB is my total SGA, that means nearly 3 GB or 4 GB or even 5 GB is my what? Buffer cache. Huge. Imagine, so 8 KB is one chunk and total buffer cache is of 4 GB or 5 GB, 5 GB. So many thousands and millions of buffers it will contain. So much, huge area. Fine. Now, wherever the server process want, can he simply keep the data whatever he brings? No. There is some mechanism in using those buffers. You can't simply randomly go and take the buffer you wanted. No, not possible. What is that? Now, in this buffer cache, whatever the memory is given, some memory area of my buffer cache is used to maintain some information about the buffers. Right? Reserved. Some area is reserved to keep. Simple man, if you get a book, notebook to note, I hope most of us will leave the first page, especially schooling kids. Remember school time even, we leave the first page or not? Right? Have you started writing from the first page? You started writing from the first page or no? Second. School generally we see, right? What we do? On the first page we write our name, right? Class, school name, class, which book it is. It is a English, classwork or rough book or which kind of book it is. Yes, no. Information about the book is maintained or not? Generally what we do, we open the first page. Oh, this is a rough book, keep it. Because all are covered with the same color paper. School days or even nowadays, right? So it's difficult to identify which one is that. So we just simply see first page. Okay. Nowadays we are getting a sticker. We can stick it on the front only on the book. But general case, okay, just story purpose, right? First page we are reserving or not? Yes, we are not, right. Same way, the entire area, some memory is reserved to keep information about its own buffers. Leaving that remaining memory is used to keep actual data. Now, what is there in this memory area? A list is maintained. I'm just writing it here bigger, larger to understand. What it is? A list is maintained. A list. This list is called as LRU list. What do you mean by LRU? Least recently used. Least recently used. Okay. LRU, a list. Now, what is this list contain? All buffer addresses are maintained. What it is maintaining? All buffer addresses. They are just maintained in a order. Yeah, you can. They are just maintained in a order. One end the buffer address will be most recently used buffer, and the other end is going to be least recently used buffer address. Getting my point, right? One end most recently used buffer, and the second end is a least recently used buffer address. A list in some order format. Normally, if you go to the schools, man, attendance register, it is in some order or not? Normally, alphabetic A to Z, the still kids' names, not randomly, or it could be on enrollment number, enrollment ID 101, 102, 103, that order. Some order, it is recorded. Even the score sheet on the board, right? High scorer to the lowest scorer, not random, correct? Some order generally, yeah. Same way here also you see an order. What is that one? The one side the buffer address of the buffers are maintained, not the buffer, correct? Okay, address of the buffer. What is that? Most recently used to least recently used. Simple, done. All buffers, whatever it may be, let's say some 10,000 buffers are there. All those 10,000 buffer addresses are there in this list in an order MRU to LRU, and this list is called as LRU list. Done. Now, server process, after generating, coming up with an execution plan. Once I found an execution plan, I'll go to the disk, bring this data to where? Into. Now, after bringing this, which buffer should I use? My server process will always go through what is that? Whenever it do an IO, it will go to what? LRU list and simply take the address from which end? Tell me please. Little
Least
louder.
and
Which end?
least
LRU end. Correct? This address example, this is the buffer. So simply what it will do, it will simply take this and it will keep this buffer, whatever the value here, whatever the value, I am going to just place it here. Then as the buffer got used or touched even by server process, what happens? This buffer is simply taken out from this end and recorded into the most recently used buffer address. Correct? Understood? So server process, whenever it is doing an IO, taking the blocks, it will go to the LRU list and goes to LRU end and it will take the buffer address, and whatever the address, example, this buffer address is here, it will go to that buffer and place this data. As the data got placed, immediately the buffer address is moved from LRU end to MRU end, saying most recently used. Got it? Now, if I follow with the same select query, right, might be I'm going through a index scan or table scan, whatever it is. So this block was loaded going through index. So this block is the one here where I kept my data. If the same query got submitted by user, will it find the data in my buffer cache or not? Yes or no? Tell me please. The same query is submitted requesting for same data, employee ID 101, this is the block. So will they find it from the buffer cache or not? Yes or no? Yeah,
Yes.
it will be found directly from there. Correct? Yeah. And other users are also parallelly working. So many queries are running. Different. So if other users are reading data from other table or another table, right? Whenever their server process brings this data, what happens? They all go to which list? LRU list, and which end? And they will start using these buffers. Correct? And these buffers, as they got used, they all move to which end? MRU end. This is my first one. Let me keep little longer. The first one. Still it is there in the one in the list, and the buffer contains still the value, my old value. Agree? So Oracle is trying to keep your data for a maximum period of time, because let's say this user has brought this value kept here, and I don't want any other user to go and take and simply overwrite the same value immediately. I don't want that. There should be some mechanism. Correct? Right? There is no partiality here. Right? So that's why they have this list. What is this list called as? LRU list. So as your buffer is loaded, the address is moved to the MRU, and so that these other addresses can be used by all your other users. So your data will be there, right? I'm not updating this one immediately, correct? It is there for a long time. How long? As long as all these buffers are done. Used by other sessions or same session for same different data, not same data. What happens now? So all these buffers are moved on top of this, yes or no? Right? So slowly seems like this buffer address is slowly moving down. And when it reaches to which end? Till that point, your data is still safe and available in your buffer cache. Then now it reached to the LRU end, and some user is firing a reading data from some other table. What happens? It will go to LRU list and it will simply use this buffer. So what it will do? It will override this value, this block, with some other table data. Correct? Now your first query you submitted, the data is no more in your buffer cache. Why? It got overwritten. It got overwritten by some other user's table data. Some other table data. Got my point? So buffer cache and the LRU list is very important here. The LRU list will ensure that your data is not getting overwritten immediately, trying to make sure it is maintained for a long period. How? By LRU end and MRU end. Right? So once the buffer is used, it moves to the MRU end, and right, MRU end, and all other users will start using the other buffers, not the same buffer. Then now during the journey, because what happening as these buffers are used by some other sessions users, right? These are going on top. This buffer is slowly coming down here. Let me in this position, might be in this position after some time. So many buffers got used. So slowly it is moving from top to down. Got it? So this is the place. Now what happened? Same user or any other user requested for the same employee data. Employee ID 101. Is the buffer available for that block in memory or not? Yes. What I will do? The
Specified.
same record, the previous record S X, right? I'm using. So that value is used. As the buffer got reused before it reaches to the LRU end, if it reused as it got touched again, it is again moved from here to which end?
MRU.
It is moved again to MRU. Got it? Again, the journey starts again from here. The buffer address is slowly coming down somewhere here or somewhere near to end. Again, someone requested for the same data. It is available as it got reused again. It is moved again onto the top. So this way you're trying to ensure, again, Oracle is trying to ensure that your frequently used data, frequently you're accessing, every 5-10 minutes you're accessing, correct? So every 5-10 minutes, what happening? The journey here. Example, the journey takes here totally 15 minutes to reach here. Within 10 minutes, you read again. So it will again go back. Again within 5 minutes. Again 10 minutes. Again 12 minutes. Getting my point? So your frequently accessed data is maintained in memory for a very long time. Done? Understood? Right. Maintained in memory for very long time. Okay, now if it is not used or might be other users are reading huge data and so much of data. So obviously this your buffer, let's say this is the one address, slowly reached to the end and it got overwritten by some other value, Then is your first query data available in memory now? No, it's not there. What happened? It got overwritten by some other data. We call it as aged out. What we call? Aged out. It's no more there in memory. Aged out. So before it get aged out, if someone reuses this data, request for the block, then it will be again moved to which end? MRU, and if not, if it is not getting reused and when it reaches to the LRU end, still it is not used and some other user requested for some data to be read from IO and then it is going to be get overwritten, that is called as aged out, age out. LRU. What is the question I asked you today morning? Dash plus dash. See how fast you are able to say.
M
Why?
plus 10.
It is there still in memory. Correct? If I go on asking you every day, so it will be there in memory. You don't need to refer book again. Why it is there here? That's what you should do again. You understood that concepts here? Fine. How long it will be there in memory, man? Can you recollect or just tell me today what you had in your breakfast? What you had in your breakfast? Idli. Okay, some fine dish. Can you tell me what you had yesterday? Recollect somewhere in memory. Found something? Yeah. Can you tell me last Monday what you had? No, not possible. Aged out? Yes or no? It got aged out. Right? Same way, the concepts what you are hearing looks good now, might be even today. After 2-3 days, also somewhere fine, little bit blurry. After a week, after 10 days, you'll nearly forget it. Something sir told. What is this? Something, some cache. What is the buffer cache? Yes, sir, I got it. It's buffer cache now. Correct? So what happens is our memory is designed that way. So it gets aged out, the content gets aged out. So what we have to do, we have to refresh. That's why I ask you to please go through the videos once again. Don't go through 3 times in the same day, not required. Just go it today and then might be after a week or after 10 days. When you feel, okay, it's nearly blurry kind of thing, nearly forgetting, just go through it again. Read it again, go through it again, read it again, right? It will be there for very long period, right? Main thing here, the game is completely here. So that's why people ask us to redo, right? Please do that part, right? Okay. Now back to our concepts. I hope you understood the LRU list, LRU end, MRU end, a buffer, how they are used, a list. Clear? Right. Okay. Now let me come up with a DML. I hope you understood the select, how the selects are running in the previous one, right? Before this, we discussed about the select. Even you understood the buffer cache, how memory is actually helping or used. Let's move to the next part, right? Let me start with a DML part. What do you mean by DML? I'm going to do some update. Let me write the statement update. I'm going to say EMP. What is that? Set salary equal to $2,000 or what it may be, 2000, where who is that guy? Employee number equal to 101. Is that correct? When you submit the statement, what happens? Selects, for every select, parse code, parse, execution plan, fetch. Now I'm just doing a DML. It will do only first two because there is no returning of fetch. There is no returning of data anymore. That is fetch operation, right? So, okay, what it is doing first, it is going to parse the statement, validate the table exists or not, column or not, permission, that user have permission to update this table column. All those are done. Then what I will do, I have to bring this data and update. Simply go to the table and update. So what is that? It will take the table block and brings it. So whenever it is doing an IO, please keep it in mind. Who is loading this data from disk to memory? Fast. Who is loading data from disk to memory? Server
IO.
process 2. And whenever it is doing an IO and loading data into buffer cache, it will go to what? LRU list, must. Is that correct? Yeah. LRU list. So now it will take this buffer address, let's say new story completely now. This is the buffer address. What is that? This is the buffer. I'm just keeping it a bigger size, right? And I'm going to place the data. What is the old value? Let me say this is the one old block. This is the block which contains this employee number 101, and the old value here is 1000 in that one, which I'm trying to modify to what? 2000, correct? So when I done this one, it is going to take this block and then go to the LRU, this buffer address, then I'm going to place it here into this area. Once I placed it here, what is the old value? 1000. And what you're asking me to do, change it to 2000. I can simply go and modify it to 2000. Done? Modify done? Then after a few minutes or some time, you realize there's something mistake happened. Sorry, I don't want this update. Revert it. What you do? What is that command? Rollback command. Correct? But when you say rollback, you are simply commanding Oracle, hey Oracle, please, whatever the change you did, right? Revert it back. I don't want that. But how Oracle will know what is the old value? You already modified to 2000. What is the old value? Oracle should know to revert it back, right? So what Oracle will do here before modifying this, what is that old value here actually? Before I modify any data, what I will do, I will go to another file. Let me keep this 1000 on the side. 1000 old value. So I'm going to the another data file and there is another object available. Object, please follow my words, right? This is also a set of tables, nothing but objects, 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 indexes also objects, right? Everything is object. We got another type of object and from that object a block is taken and loaded into the buffer. Again, let's say this is another buffer here. Right? Let me just draw these lines again. Correct? Okay, this is the buffer, first buffer I got it. Then I'm going to do again an IO and load the block from this another object, right? So let's say I'm going to take obviously the next buffer, correct? Next buffer. So let's say this is the buffer address. Here is the address, this is the buffer, correct? So what I will do after bringing this block here, it is just completely blank. There's nothing in that, right? Okay, what I will do, I'll take this value first and write it here into this. I'll take the data from there and make a copy of it in this. And then I'm going to say what? 2000. Your old data are before value. This is the current value. Before that, what is the value before? 1000. is recorded in another object block. Another objects block. Why? At any time now, if you say rollback, if you say rollback, I can simply revert it back. Yeah, I can simply revert it back. So this way we got another set of objects which are used to roll back. In older versions, we used to call them rollback segments. What we call rollback segments. Now they are renamed, calling it as a simple undo segment or undo objects. What objects? Undo objects. Undo, you know, right? Undo, redo, word we have, redo, arrow marks are there, right? If you want to undo, just undo, redo, redo. Correct? Same thing here. We got another object called undo object. Undo object block is taken from there. Undo block is loaded. Undo block is loaded. And the old value is first recorded in the undo. Then table block is modified to 2000. Correct? This way the old values are maintained in the undo block now. How long this data is maintained? Till you end your transaction. Till you end your transaction, nothing but when till you mention commit or rollback. Because at any point of time you can say, hey, please roll back, right? And if you don't want to roll back, what you say? Commit, nothing but like a saving a file permanently. Commit. When you say commit, this data is no more required till the time this before image data is maintained. Where it is maintained? In the undo blocks. So please understand, we are talking about what? Undo objects or undo data. The data which is, this is a before image. How long it is maintained? To support two things. One, it is going to support for what operations? Roll back. Because this is the main purpose. Undos are designed. At any point of time, you say, hey, sorry, roll back, roll back, roll back. Yes. I'm simply going to make a copy, revert it back, done. Rollback purpose, right? Undos. I said one more term here. What is that? Transaction. What is transaction, please? Okay, transaction is a transaction. Normally we do banking transactions. We know that from that point of view, we know. Okay, same way here. What is that? Whenever you submit any DML here, see please, right? Your transaction is just a term, definition, explanation. What is that? Your transaction starts, what is it? Starts with a DML. Starts with any DML. Your transaction starts with a DML. Simple. Right? So it could be insert, update, delete, whatever it is. Your transaction started. You might be updated only one row. Next, what is the statement you are going to submit here? What is the next one? You might say another update, or might be next you will say what? Insert. Might be you are going to say select. What it select is not required, not use added into this. Might be you might say what? Deleting some other record. And finally, you are going to submit here what? So your transaction starts with any DML, and your transaction will end. This is your start, and this is going to be your end. Your transaction starts with a DML, and your transaction will end with a commit, or you might say rollback, or you might type example exit. In SQL prompt, if you type exit, remember when you type exit, there is an auto commit is there. It will automatically do a commit for you. So nothing but when you type exit, it is a commit. So commit or rollback, whatever the scenarios, your transaction is going to end. Understood, please? Simple. This operation, this duration is called as a transaction. So a transaction starts with a DML and ends with a commit or rollback or exit or few more. That ends. Transaction is over, completed. Now the transaction can have, because transaction starts with a DML, so one DML you already submitted, a transaction can have a single DML statement in it or multiple DML statements in it. The transaction will have one or multiple DMLs in it. Might be I said update and say next commit possible. So by this transaction contains only one DML, correct? Or the another example you see here, update, update, insert, update, delete, and finally commit or rollback. So a transaction having what? Multiple statements DMS in it. Done? During this point, till the end of your transaction, your data is maintained in your undo. Why? Because at any point of time, you might say, instead of saying commit, you might say what? Rollback, I should be able to revert it back. Done? Clear? Okay. Transaction undos. Okay, now these two blocks as they are used, these two blocks are immediately moved to which end? MRU end. Let's say these are the two blocks. Correct? Now let me say few more things about buffer cache. What is a buffer cache? A chunk of buffers, right? So each buffer, they have different statuses. What is that? Status or state. The state, right? They are into. What is that? Initially when you start up your instance means memory and background processes. Architecture, please, day one. Instance means SGA plus when you start up your instance to work with your data, this memory allocation is done. The 5 GB buffer cache is allocated or assigned. Now, do you have any data initially in the buffer cache? Nothing. So the buffers are basically initially they're all what? Free buffers. But as you start doing select, the data is taken and placed here. Let's say the data is placed here in the previous example. The buffer is marked as what? Used buffer. So most of the time buffers are basically in the initial stage, the buffers are in a free, but later on you will be having what? Used buffers, right? If it is a used buffer, example, this is the one, let's say this is the one earlier before the update. Before update, right? This buffer was here, correct, in the LRU end. And if I submitted this DML, what happens? The block is taken, right? And the block is going to be placed on this one, correct? Yes or no? Right? Before DML, I'm just rewinding it. Before DML, assume that there was some select happened, not this block. Let's say this is the block. That block is nothing but here. There is no value in this, right? Let's say the same sign. This was the block or buffer, and this is the address before update. There is some data. So what is the status of this one is? Used by some query, used by some table data, right? And then I find my what? Update. So the table block was taken here, and then it will simply, as it is in LRU end, I am going to overwrite it with 1000 value here. Correct? The previous table data got overwritten or not with my this one, right? New table data, and same before I modify, undo block is also taken the same way. It might be a previously used one. Now it got overwritten by undo block, and then 1000 was recorded, and then here it is got what? Right? The earlier before DML, these buffers might be what? Used one by some other table data. Correct? Now, as you find a DML, there is a small change happening. What happening? The blocks are taken, LRU list, the buffer could be what? Free, or a buffer could be used. I'm going to simply write the data. So table block, undo block. Copied here. After copying, what I'm doing? After copying, I'm writing the 1000 value in this. Correct? And then I'm updating this 1000 to 2000. You are changing the data inside the block or inside the buffer. You are changing, modifying, correct? when you are modifying this buffer, because there was nothing here, you modified, because when I bought it from the disk, it is completely blank. And what you did, you wrote 1000, you modified here, then this buffer, as you modified, these are modified buffer, we call it as a dirty buffer. Which buffer? Dirty buffer. Modified. Then table block was 1000. When it is copied, simply copying, simply loading data as it is, you're not doing any change. Correct? But if you modify this one to what? 2000, this buffer is also marked as what? Dirty buffers. Dirty buffers in my buffer cache are those buffers where the changes are happened by your DMLs. Correct? Because actual value is 1000, it was loaded. If you did a select, the block will be told loaded and the 1000 value is given to the user. What is the salary? 1000 is given. Done. There is no change in that. But if you are doing an update, the 1000 value is modified to 2000. Those buffers are marked as dirty. So different states you see here. Again, while modifying, initially it is first writing it to the undo. It was blank. It is writing the 1000 here now. While it is updating this buffer, right? I don't have enough space. Let me clean. While updating this buffer, initially the status will be current. What do you mean by current? Currently, it is modifying this buffer. The state of that buffer will be what? Once the modification done, the state is changed to what? 30. So it is like a in-memory modification. It could be done in a fraction of a second, millisecond, nanosecond kind of thing. But for that duration of when I'm modifying, it is current. Once it is done, 30. Then I will go to the table block. It was actually 1000. So I will have to modify to what? Modify to? When I'm modifying this, the status will be what? Correct? While I'm modifying, once it is done, it is marked as 30. So different status or states, the buffers will be in your buffer cache. What are those? One is free, used, current, and dirty. And understood? Shall I continue? Okay, now next. Different states we got, right? Now what happening, right? So many users are working. Let's say these are the two dirty buffers. These are the one. These two dirty buffers are moved to which end? MRU, as they got modified MRU end. Correct? Like that, slowly these buffers are moving on top by many other queries. Right? Okay. So these dirty buffers are slowly coming down. Might be somewhere here. Again, after 5 minutes, again here. At the end, they reach to which end? LRU end. So these two dirty buffers are again came back to which level? LRU end. Got my point? The user who did an update is not yet ended his transaction. Means he didn't give commit or rollback. I'm the one who did an update. I forgot to say commit or rollback. I just left as it is and I'm doing something else. Might be. The transaction is still open, active. It's not yet completed. Right? Okay. So data is as it is. Still the dirty buffers are as it is. Got it? Now next. What is that? Might be the same user or some other user requesting data from different tables. Select. Other users are working. Correct? Fine. What happens? This table block, example, this block is taken loaded by doing an IO. By whom? Some server process. What happens now? Tell me, guys. When it did an IO on the some other table data, bringing it here, what it will do?
Go to the LRU and check.
It will go to the LRU list. Yes or no? Please,
Yeah.
you have to be active, right? So it is going to, whenever you do an IO, it will go to the LRU list, go to the LRU end. But what is this buffer marked as? Dirty. That means there is already a change in that one. You should not allow it to write by some other table data, because this is a different data, right? Different table data. I'm not going to allow. So it is going to server process will skip this buffer as it found it as a dirty, skip. Then go for next. Again, this is also dirty,
30.
skip, right? Okay. What happened next? Next also I found it as what? Dirty. So
30.
I can't overwrite that buffer, whatever the buffer address, wherever it is. Address, sorry, I can't. Then go to next. Might be I found this one also was dirty. There
30.
might be so many dirty, because there might be so many DMLs are happened by many users. Dirty, 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 dirty. Server process. What it is doing, whenever it is doing an IO, bringing any data, right? It will go to the LRU list, LRU and it will try to take the buffer. As it finds dirty buffer, it will simply skip, go for next, try for next, next. This way it will try for, it will give 4 attempts. How many attempts it is doing? Try, no, dirty, leave it. Next, oh, dirty, leave it. Next, dirty, leave it. So there are so many other buffers also dirty. Thousands of, I told you, thousands and millions of, right? So I can't go on searching each one by one, next, 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 next. There might be hundreds of buffers dirty. I can't go on checking one by one. I don't want to waste time. What it will do? Simply server process when scanning the LRU list. Please be with me. With server process when it is scanning the LRU list from the LRU end and it found dirty, 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 it will give 4 attempts as per the Oracle book documentation. After 4 attempts, still if it is unable to find a
Use free.
free or used, it can't use the dirty one, right? So free or used unable to find, server process will go and simply invoke this process. Who is this guy?
DB writer.
First process. So DB writer is invoked by whom? Invoked by server process. Keep it in mind. DB writer is invoked by server process. This guy is always in a sleep mode, like Kumbhakaran. Always sleeping, someone has to wake up. Stories we seen same way. It's in a sleeping mode, so someone has to wake him up. Who is waking him up? Server process. When server process unable to find any free or used when going to the LRU list from the LRU end. After 4 attempts, again 1, 2, 3, 4 attempts, unable to find, it will invoke DB writer. Hey boss, please come up. Now whenever DB writer is invoked, what it will do? DB writer job is to simply go to the buffer cache, right? Take the dirty buffers. Which buffers it is going to take? Dirty buffers. Take all dirty. There might be so many dirty buffers, correct? So many dirty buffers, so many dirty buffers, right? It will take all dirty buffers and write them back to the disk. Write them back to the disk. So whenever DB writer invoked, it will go to DB buffer cache, take dirty buffers and flush them, write them back to the disk. So this block came from which block, which object?
Undo.
Undo. So this block is written back to undo. So what value you will see here now? 1000. And this block came from where? Table. So this block is again written back to the table here. What value you will see in the table now? Flushed everything. That is the job of my DB writer. Once all dirty buffers are flushed, they're all marked as what? Free now. They're all free. Right? Now I'm going to signal, hey, I'm done. You invoked me to do task. I'm going to acknowledge you. So DB writer will acknowledge whom? I am done. Let me go back to sleep. Right? Okay. Once it received an acknowledge, till that time, what happening? Server process is waiting there. Example, there is something like dust is here, not cleaned properly. I'll call up our office by a person, right? Hey, can you please clean up? I have to do some work. At my desk, example, it's not cleaned up, or there's something fell down, right? So what I'll do, I'll call up the person to clean. So I'll be moving out. Please, can you clean that? Yeah. So that guy is doing what I'm doing. I'm waiting for him to finish the task. Once it's done, okay, then I can jump into my desk and I can start my working. So till the time server process is waiting till DB writer finishes flushing out all dirty. So wait. Once it is done, then as he received acknowledgement, sent a acknowledgement, I am done. Then server process will take the block, go to this LRU end, which are marked as free, and now it is going to place the other table data. I hope you understood. Following me, everyone, online, offline, guys. Correct?
Yes, sir.
Right. Okay. But the user who did a DML here in our story, is he committed the transaction?
No.
Is not yet done. What happened? Your values are written back. See here, a lot of guys get confused. They will have a lot of doubts. Hey, the user is not yet given a commit, but still the DB writer, is it going to write it? Many people say no, they won't write, but it actually writes. DB writer doesn't know what you did. My job is to take dirty buffers and simply flush it out. Your uncommitted data is also written to the disk. Your uncommitted data is also written to the disk 2000, 1000 done. Okay. Now you don't have this table data in memory. Please remember it is already flushed. It is already flushed. Clear? Now after this, if this user or any other user, let's say the same user, same session. This session who did this change, right? Updated. Now this user says select. He want to see what is the salary. After half an hour, he realized, okay, there was some change happened. I want to see the salary. He did a select. Now tell me if the same session do a select, what value should be given? New or old? You did an update, man. You did an update, right? From 1000 to 2000 salary, one row updated you got. And if you fire next, if you fire select salary, what value it will show? 1000 or 2000 for you now?
It should be 2000.
1000 or 2000? Just again, think again, please.
Oh, for the same user, it will be updated one.
I am the one, yes. I am the one, I am the user. I just did an update. Salary updated from 1000 to 2000. I got an acknowledgement, one row updated. Done. And next prompt, I'm going to type select salary where employee ID equal to what value it will show me? 1000 or 2000?
2000.
2000. Whatever the changes I did, I can see or not? Yes, if I
Yeah.
file. Same session again, that is allowed, please, condition. Allowed only for the same session. The session through which you did an update, if he fires the select, the same session fires the select, what value is given to him? New or old?
You are.
New value. So 2000. Now, what happens? The server process will check out the parsing code, execution plan. Now it is going to check in buffer cache. Do you have the data in this? No. So it will go to where? Table. It will do an IO. Bring this block here. What value you got here now? 2000. 2000. Sorry. Yeah. This 2000 is given back to the user. Right? It will do an IO and bring the data. Other users or other sessions, if they do a select, what value should be shown to him?
1000.
New or old? Old value only. All other sessions, you can find only the old because this user is not yet committed. He is not yet committed. Done? Okay, what happens for other users? Simply it will find, okay, that row is already locked because there was a modification done. It will go to undo. So this undo block is taken and loaded here. What value? Kept here, prepared as a buffer, and then this 1000 values given to them. So whichever the users, when they query, the data is loaded from the disk again back to memory and served them. Correct? So like this, your undo data, even though if it is in memory, fine. If it is not there in memory, it is loaded from the disk to memory and served to other users. Right? So simple job what? DB writer whenever invoked, flush out all dirty buffers to disk. There might be some committed transactions, ended transactions, or there might be some running transactions, uncommitted transactions, whatever it is, everything is flushed to the disk. Flushing out the changes. Any change happened, flush it. Any change happened, flush it. Any changes are there, flush out. Done by whom? So please understand, DB writer taking data from memory and writing to where? To my disk on the files. Right? Who is reading data from disk to memory?
Server
Who
process.
is reading data from disk to memory?
Server process.
Server process loading data from disk to memory. Now who is flushing data from memory to disk?
DB writer.
Please be clear with that. Done? Few more minutes, guys. Right. So we understood DB writer job. Now server process is the one who is invoking. Whenever invoked, his job is to take dirty buffers and flush out. But how he will find what are the dirty buffers? Right? But LRE list contains so many dirty and so many normal buffers also here and there. Right? I can't go on scanning. It's a huge one. Example 10,000 buffers. Example I told. I have to scan all 10,000 buffers, out of which might be 10%, like 1,000 buffers are dirty. But I need to scan the total 10,000 to find out which are those 1,000 dirty buffers. Time taking or not? Right? So it's a time taking. So I don't want server process to wait to scan the entire 10,000 to find 1,000 there. Time taking. So what Oracle is doing, there is one more list is maintained. One more list is maintained in your this one. Two lists are there. One is, what is that one list? The second one is called as a checkpoint queue. The second one called as, many of them, they won't explain you all this, mind. But please focus, concentrate, understand. Right? I'm trying to give you a detailed, a clear explanation slowly, one by one. Right? And I'm sure even that, I'm sure after 10 days, you will forget more than 50% of content. Lot of content, man. Right? But revision should be there. That is the main part here. If you miss, you're gone. You're back to zero again. You must revise, right? So back to the things, please. We got one more list. What is this? Checkpoint queue is another list, and this will contain only the dirty buffer addresses. Only what? Only dirty buffer addresses. So what happening now? Whenever DB writer invoke, it actually goes to checkpoint queue. It will get all DB dirty buffer addresses, all 1,000 buffer addresses I got simply, right? And from there, I'll go to all those buffers, each and every buffer, wherever it might be this one dirty, there might be somewhere dirty here, one more dirty here, all this. It will take all dirty buffers and flush out the disk. Right? When loading data, server process bringing data, it will go through, and DB writer when flushing out, it will use checkpoint queue, which contains only dirty buffer addresses, and simply flush them back to the disk. Done? Now DB writer is invoked on some other cases also. What are those? There is one thing called as there is a threshold limit. Threshold limit. It's not defined in any book or any Oracle publications. They simply say there is some internal, there is a limit when your dirty buffers reaches some value, percentage or value, whatever it is, limit. It's not defined anywhere, right? So they simply say what? There is an internal threshold limit. Whenever it exceeds that limit, automatically DB writer is invoked. That is another mechanism. Fine. There is also one more DB writer invoked whenever, what is this? Invoked by checkpoint process. We have other processes, right? Log writer, checkpoint. So DB writer is also invoked by checkpoint process. Few more, but mainly, yeah, we consider this. So my database writer is invoked, three things, remember. One, invoked by server process, invoked by some threshold limit, internal threshold limit, right? And one more is invoked by a checkpoint process. Right, let me stop it here. So what we covered up, we talked about today buffer cache or buffer cache. which consists of free, used, current, dirty buffers. There are two lists are there, LRU and checkpoint queue. Server process, whenever it is doing an IO and loading the data, it will go to the LRU list. And if it is finding any dirty after 4 attempts, it will invoke DB writer. Will go to, when it is DB writer invoked, it will go to checkpoint queue, goes through all the dirty buffer addresses, take those dirty buffers and flush. Once flushing is done, it is going to acknowledge back server process, I am done. Then server process will go through that and load the data again. So server process job is in loading data, DB writer job is in flushing data. Any changes done, right? It is going to flush. Server process loads, DB writer flushes. Done. We'll stop it here today.